Hello, 7th grade math students. Here is the first part of Chapter 2 guided notes. This is Chapter 2-1A, Simplifying Rational Numbers. Pretty straightforward today. You may have done this in the past, and that's okay. Make sure that you're putting your name at the top of your papers. I'm receiving lots of papers back without names on the top of them. I'm telling you to do this in the guided notes right now, so that way you remember to do it right now as well. So our objective today is learn to write rational numbers in equivalent forms. Our essential question is, how do you simplify fractions? Okay, so rational numbers are any numbers that can be written as a fraction. We're going to use number over, or the numerator over our denominator, or the numerator and denominator are integers. Our denominator can't equal 0 though. Our n stands for numerator, our d stands for denominator. These need to be integers or whole numbers. They can be positive, they can be negative, they just need to be whole numbers, they can't be a decimal. We can also make sure that our denominator cannot equal 0. So the denominator cannot be 0. An example of a rational number is something like 1 over 2 or 3 over 3, which gives us 1 whole. Numbers that are not rational numbers are anything like 4.6 over 5, which is not a whole number and not an integer on the top. Or we have something like 5 over 0, where a denominator is 0. That's not a rational number. So what is the goal of simplifying fractions? Our goal of simplifying fractions is that it's easier to work with fractions when they're in their simplest form. So, here. Relatively prime numbers have no common factors other than 1. Some examples of these would be 3/4, okay? Where we have a fraction, we also have our prime numbers such as 2, 3, 5, 7, 11, 17, and we can keep on going to numbers that are prime as well. If we're going to simplify a fraction, like we are down here, number 1, we have our fraction of -6 over 8. We can see that both of them can be divided by 2 or simplified by simply dividing the top, the numerator, and the denominator. So let's go ahead and try that right now. I'm going to simplify and make them smaller. 6 divided by 2 is going to give me a -3. 8 divided by 2 is going to give me a 4. Now I can't reduce my 3 anymore because 3 is prime. So this is as far as I can get my answer, as far as I can reduce or simplify the fraction of -6/8. If I look at my second example, -24 over 32. I'm a smart cookie. I can see that I can divide each by 4 right off the bat. Okay, I know that 24 divided by 4 gives me 6. I know that 32 divided by 4 is going to give me 8. Whoa, I end up with -6 over 8 again. We can still go back and say, hey, I know that if I divide each of these by 2 again, I know that I can end up at -3 over 4. Now in your practice problems today, not every number is going to be nice, neat, and simple like that. If you flip to the back side of your packet, your practice today, you might notice that 11 and 22 are both divisible by 11. Even though 11 is prime, you can still divide it by itself. you might see that there are some odd numbers here. Some of these odd numbers may be divisible by 3. You have to double check. We have prime numbers such as 17 over 51, so that might be in its simplest form already. Make sure you complete A through L, and then when you're finished, make sure you complete the summary at the bottom of how do you write a simplify fractions, okay? When you're finished with that, make sure that this goes back in your folder so that way you have it for Friday. If you have questions or need any help with anything, make sure you rejoin the Google Meets in order to ask for some extra help or support, or send me a quick email and I'll get back to you as soon as possible. Thanks, guys.